Hello, and welcome to World of Warbirds. I'm Brian Pierce. Hello, my Warbirders. So, as you can see, this episode is a part 2, and this is a first. Unlike all other multiple parters, this part 2 is not about the same airplane as part 1, and isn't even based in the same country or even the same theater for that matter. It's more a part 2 of a concept, and we'll have to see if it works. Please let me know one way or the other. Remember that if you become a Patreon member, you have quicker access to me, early episodes, and exclusive bonuses, and become a valued member of my crew. Please consider joining. You'll also get shout-outs. And in that light, I would like to thank Leon, Jordan, and Brewster for stepping up to help support the podcast. In our last episode, we ended up by wondering what would have happened if the Shinden had been allowed to mature and develop, and especially what would have happened if a turbojet engine had been installed, as was perhaps the intention. Of course, Japan's aviation industry at the end of the war just wasn't in a position to do that. But we do have an indication of what it might have looked like if we shift geographically half a world away to Sweden and back up in time a bit to September 1939. At the outbreak of war, Sweden's Flygvapnet, or Air Force, found itself fairly short of modern fighters both in numbers and quality. And even though Sweden was neutral, even neutrality can only be assured through the capability to defend oneself. So Sweden embarked on a crash course to beef up its fighter force through a variety of programs. The first program was to purchase. But with all the, war going on, who wants to sell valuable airplanes to a neutral country? Manufacturing countries want to first provide for their own inventories, then maybe offer to their allies, and then after that, only to neutrals. So the only thing the Swedes were able to pick up were some obsolete Fiat CR-42 Falco, which means Falcon, biplanes from Italy which were fairly useless against modern monoplane fighters. The second program was to quickly build a stopgap conventional fighter with non-strategic materials, and this was the FFS J-22, which looks like the results of a FW-190 and a P-47 mixing it up. No, not in a dogfight, but in a little boom chicka wow wow. This one probably deserves its own episode one day, and so we will add it onto the list and move on. The third program was something a little more ambitious, and it is the star of today's episode. Supposedly SAAB had been pondering a pusher configuration monoplane for some time. This would be built around a British Bristol Taurus radial engine and would hopefully have all the advantages of having the engine placed behind the pilot that I listed in the Shinden episode. Especially excellent pilot visibility and the benefit of concentrating the firepower in the aircraft's nose. Work on this aircraft began in earnest in 1941, and one of the first things that needed to be secured was an engine. With a goal of attaining 300 miles per hour or 480 kilometers per hour, the Bristol Taurus just wasn't going to cut it. The American Pratt & Whitney R1830 Twin Wasp radial engine was then chosen as a primary power plant option. But, not wanting to place all their eggs in one engine basket, they also negotiated with Germany to get their hands on the Daimler-Benz DB605B, which was a liquid-cooled V12 engine generating an impressive 1,475 horsepower. This was the same engine being used in the BF-109, 110, 210, and a bunch of others. As was previously said, getting deliveries of these engines was a slog, considering that supplying the German and Italian aircraft industry would be priorities before selling any to a neutral. So after considerable feet dragging, sample engines were finally delivered in June 1942, and they didn't work. Supposedly, they had been sabotaged by the slave laborers working on the Daimler-Benz assembly line. With the blueprints, and finally getting some non-defective examples from Daimler-Benz, construction of the engines by Svenska Flygmotor, later known as Volvo Aero, finally began. Meanwhile, work was moving forward with the airframe, although the SAAB 21 was to be a fairly unconventional-looking aircraft. It wouldn't be as unorthodox as the Shinden, which didn't have a tail at all, and had canards and wing-mounted fins and rudders. No, the 21 was to have twin booms supporting an elevator and twin tail fins, just like the P-38 Lightning. Just ahead of the pushing engine was mounted the laminar flow low wing. Like the Shinden, the landing gear was to be tricycle, except that the main gear would retract back into the booms. The wing, as seen from above, is interesting, as the leading edge of the wing root extends straight out to the boom, then sweeps back in a fairly pronounced manner, giving a sleek, almost boomerang-like planform. Drag reduction measures throughout gave the 21 a very clean look. Oil coolers and engine ducts were built into the wing sections between the fuselage and tail booms. 130 US gallons, that's 510-liter, internal fuel tanks were included, and two 42 US gallons, or 160 liters, or two 110 US gallons, that's 400 liters, drop tanks could be carried. Initially, armament was one 20mm cannon with 60 rounds per gun, and two 13.2mm cannon with 350 rounds per gun in the nose, and one 13.2mm cannon in each wing with 325 rounds per gun. Later on, the nose 20mm ammo load was upped to 140 rounds per gun. For simplicity's sake, I'm lumping together variants, but overall, the 21 could carry a wide variety of weaponry on hardpoints located on outer and inner wings and belly. Bombs that could be carried ranged from little 110-pound ones on the wings up to a 1,300-pound one on the belly. A variety of armor-piercing, semi-armor-piercing, and high-explosive anti-tank rockets could be carried. Can I just say that I love the Swedish word Sprängraket? I don't know if I'm saying it right, but it's fun to say. Even the fuel drop tanks could be used as incendiary bombs or loaded with napalm in the first place and not used as a fuel source at all. So, overall, a very impressive armament. But how did it fly? Initially, it seemed not too well. 3 prototypes were built, with 2 being flying models and 1 being used for stress testing. On the 13th of July 1943, SAAB Chief Test Pilot Claes Smith climbed in, started up, and took off. Or at least he tried. Engineers had supposedly advised him to use full flap on takeoff. I find it curious that he complied, especially with him being the chief test pilot and all. I'm no test pilot, let alone chief test pilot, but I have never taken off in any flying machine with full flaps, nor would I ever attempt it. Anyway, he did, and he barely got the machine airborne. And I do mean barely airborne, in that he struck a fence at the end of the field and damaged the landing gear. Then, on landing, he couldn't get stopped because the brakes had been damaged. Luckily enough, this prototype had an anti-spin parachute built in, so he pulled that, just like the space shuttle coming in for a landing. But I guess it would have stopped anyway, because at some point the busted-up landing gear gave up and collapsed. Speaking of things going wrong, I haven't mentioned yet how SAAB engineers had decided to deal with the problem of the slicing and dicing propeller behind him if the pilot ever had to get out. They looked at all the standard solutions to dealing with the problem, such as jettisoning the propeller with explosive charges, but decided in the end to have Bofors develop an ejection seat, and so the 21 was one of the first operational aircraft in the world to be equipped as such. And it worked too. On the 29th of July, 1946, a J-21 collided with the previously mentioned J-22. Lieutenant Bengt Johansen punched out of his stricken plane, and the J-22 pilot had to bail out in the regular fashion. Both men survived, so the J-21 was the first Swedish aircraft to perform an actual ejection. Almost 300 J-21s were built, with roughly half being attack versions, with all the bomb and rocket options listed above, and the other half being pure fighter versions. Performance was considered quite good as compared with other piston fighters, and the Swedish pilots could make that comparison. How? Well, later on they also flew North American P-51D Mustangs, and these pilots thought that the J-21 could take it on, at least at lower altitudes. The 21 had an impressive concentrated firepower, great handling, and a very tight turning circle. Apparently the controls were somewhat heavy, which would make air combat a real workout. By the time 1945 rolled around, options for an upgrade to the J-22 were being considered. One thought was to switch to a 2,000 horsepower Rolls-Royce Griffon engine, but of course there was a new toy out there for designers to play with: jets. So in the end it was decided to swap in a British de Havilland Goblin turbojet engine. In 1947, airframes began arriving for conversion. It had hoped that this process would be pretty straightforward. But as anyone out there who has fixed up an old house can tell you, sometimes it's even harder than starting from scratch. The turbojet engine was a very different animal than the previously installed reciprocating engine, and thus had many different needs, and in the end, about half of the airplane was changed during the conversion process. Firstly, turbojets drink fuel like a fish. So the fuel capacity had to be increased significantly, with tanks added in the wing center section, and wingtip tanks were also installed. The horizontal stabilizer was raised to be over the jet exhaust. Air brakes were added, as well as the flaps were extended, and the windscreen was made more aerodynamic. Even the fairly revolutionary ejection seat needed to be modified to handle and eject at higher jet speeds. The newish aircraft was known now as the 21R, the R suffix standing for reaction, which means jet in some of the non-English speaking world. The first prototype, 21R, first flew on the 10th of March 1947, and they started entering service in August 1950. Although about 120 machines were scheduled for the conversion to turbojet power, jet fighter technology was leaping ahead rapidly, and so the type was destined to be already obsolete for that role, even as they rolled out of the conversion center. The order was then dropped to 60 machines. The 21R was then slotted for the attack role, being able to carry all the previously mentioned weapons as its piston banger sister, or even a center gun pod named the Toad with 8 8mm machine guns with 100 rounds per gun. Supposedly, the pilots found the experience of firing all 13 guns at once to be, in quotes, exciting. I bet they did. The turbojet-powered 21R was about 100 miles per hour faster than the piston version and handled about the same, but endurance was on the poor side due to the Thirsty Goblin engine. Thirsty Goblin. Actually, that's a great name for a pub, don't you think? 3 squadrons operated the 21R, and it was finally retired in 1956. For such an interesting and revolutionary aircraft, it's almost unbelievable that none were set aside for museum pieces. However, in the 1990s, a derelict SAAB 21 airframe was taken on and rebuilt as a 21R by a volunteer group and is now on display at the Swedish Air Force Museum. I suppose an argument could be made that the SAAB 21 wasn't a warbird at all because it was operated by a neutral country and did not fight. I would disagree. It was designed, built, and operated as a machine to help ensure neutrality during wartime, and for that we would have to say, mission accomplished. So, does the experience of SAAB give us any indication of what might have happened with a turbojet-powered Shinden? I think it probably does. If the Japanese industry had been up to the task at the time and had been able to construct the required turbojet and then continue building Shinden airframes, but with jet-powered plants, there probably would have been a corresponding increase in performance and loss of endurance. Although as a point interceptor, that problem probably would have been less pronounced. Yes, perhaps more B-29s would have been shot down, but like the introduction of the Me-262 in Europe, I don't think it would have bought much, if any, time for Imperial Japan. Starting when it was, and with the circumstances of the time, there was never any chance that the turbojet-powered Shinden would get produced in time to join the battle. I hope that this two-parter, looking at two similar aircraft from two very different locations, was interesting to you. Aiden in Australia, I hope you didn't mind your suggestion being bundled. As for everyone else, if you do get some satisfaction out of listening to these episodes, please think of me working on them at 5 a.m. before work. And please give me a hand by supporting me on Patreon or becoming a member over on YouTube. Thank you so much, and until next time.